So we're back again today and we're building Dan Hillary's drag car engine. It's an awesome looking engine. It's got some really nice components. I've already prepped the block, done the core plug to put the crank in, checked all my tolerances and my measurement. End float's good, turns over silky smooth. Crankshafts had a polish, lip seals and the front oil seal, lip seal done as well. Yeah, it looks mega. This block has, basically this block is like our 1600R package, so our race package, cast block, O-ring grooves, wire rodded, cross drilled. It's got all the bits. So Dan, it's looking amazing. You're really going to enjoy this engine, and the components that are going inside the engine, the rods and pistons, are basically works of art. They're super strong. It's the second aluminium rodded engine that I've built. Got another one to do as well. So, you know, we're getting better and better with all the aluminium components. They grow a lot more, so I need to make sure I've got extra clearance on the squish area on the head and some other bits and bobs because they grow. But let's go and check out the block. Beautiful, prepped and painted block, ready to rock and roll. Got my special honing finish as well, so the RA number I'm not going to tell you, but it's good for ethanol fuels. I've done all my chamfers on the tops of the head studs. That stops them wanting to crack across here and across here, so it's always good to put a chamfer on the top of the on the block where the head studs go through. As you can see, these have got our copper rings that will go in here, or stainless rings depending on what we want to use. So this helps block sealing. So when they lift the head, the first place that the gases want to travel across is the closest point to the cylinder, which is always from here to here. They want to go or from here to here. They don't normally want to go across here. It's normally this one here, which is the closest, same on the cylinder head. What else? So core plugs all gone in. Cranks all in, spins absolutely lovely. It feels amazing to turn over. Really like the HX series bearings in the 2Js. The other thing that's been done as well is this has been wire rodded, so the famous X marks you get in the bore, it's because of the wall thickness of the bore between the two cylinders. I mean, it's tiny really, considering that we're holding like 1500 horsepower. And that's the thickness of the cylinders between each cylinder. It's like 6 mil, something like that. But when you've got a drilling that goes all the way through the whole block, both sides, like this way and this way, yeah, it's not very thick wall thickness. It's like 1.8 mil between the cylinder wall and this drilling. So this has been wire rodded. Yeah, I mean, I'm loving building these engines. I mean, yeah, they're awesome, you know. I feel very proud to be building these engines, and it's just such high standards as well. Been watching some Steve Morris videos. He's a really good person to watch, so if you like engine building, go over to Steve Morris and have a look at his stuff. I mean, he's building fully billet blocks, cylinder heads, machining blocks himself. So Steve is doing an amazing job. And here we are with all the components. Let's check them all out. So we have some R&R I-beam rods, big, nice, chunky, good for like, I think they use these into like 2000 horsepower range, 2500 horsepower range, so you know, 1600 horsepower, these should last about 15,000 miles, these rods, before you need to change them. And then the pistons, it's got 250 thou thick wall piston pins. And the piston design was with Manley and Jay at Real Street. They've added some extra support braces for underneath the crown. Yeah, they're lovely, just everything about them. I really like using these pistons. And this is on an 86.25mm bore, but it is gas ported, so you can see the holes there, just around. That helps the gases get behind the back of the top ring, push the ring out for increased sealing. Yeah, I mean, look at the rod. Not only that, the rods as well. I mean, they weigh 220 grams less than a steel rod, and they're a lot chunkier, a lot bigger around all the areas you want them to be big. But yeah, they're really big chunky rods, but they're massively light, you know, 220 grams lighter than a steel rod. Obviously steel rods, you know, really good for big power. If you're doing like 2,000 horsepower on a 2J and a billet block, you can get away with steel rods, but you have to have a dry sump kit. With the aluminium rods, without a dry sump kit, you can get away with it, and it just needs to put a bit more oil through it, have the clearances set and right. The only other thing you have to do with the aluminium rods is you have to machine the bottom of the liner, or not the liner, bottom of the block of the cylinder to give you the clearance for the rotating part of the rod, because it does want to hit kind of here as the rod's going around. It wants to hit on the block, so you have to machine the bottom of the block. Fairly expensive to do, but by far, you know, it's the best you're gonna get as a cast iron block. The only other thing we could do to really make this a drag block is to basically fill all the water jackets up with resin. Then it becomes a real drag block, but it's not like a drag and drive. But, you know, you won't be able to use it on the road. You'll be able to use it on methanol and ethanol fuel only, and you'll only get, you know, maybe 30 seconds of run time before it's totally heat soaked. You have to start again and cool everything down. So this is wet block, but with all the mods done to basically make sure it holds as much power as it can without any distortion or movement. Anyway, I'm going to crack on, and I've done the ring gaps. So this engine's got 3.9 thou bore clearance, 86.25mm bore. I've checked it all, I've measured it all. We're within like tenths, you know, with the equipment I've got to measure, within like 1/10 of ovality, 1/10 of taper. Block's been machined and decked and honed and bored and all the stuff that needs to be done. Lovely finishes on everything, so thanks Nick for all the machining work. It looks great. Yeah, let's carry on building this up and make sure Dan has the best possible engine that you can possibly build out of a 2J for a wet block. Let's crack on. I did forget to mention something else as well. So these rods, because they're aluminium and they grow so much when they're up to temperature, it's got a dowel pin, and that dowel pin will locate on the shell, and it just stops the shell from spinning. So when the rod grows, because it's aluminium, we normally rely on a clamping force from the shell and a couple of tangs for location, but because the rods can grow a lot more than the steel rod, then there is a chance that the shell can spin in the alley rod, which won't be good. So dowel pin in the cap of the rod, and then you need dowel bearings, and so it all slots in, locates, and then as the rod will grow up to temperature, the bearing will just get held in by the dowel, so it works perfectly. So Dan's engine's finished and built. It is wrapped up. So that's basically kind of the strongest cylinder kind of walls you can have on a stock block, without putting resin in it and dry decking the top of the deck. That's pretty much all you can do is yeah, copper O-rings or hoops and receiver grooves. That's another way of doing it. And yeah, filling up the water passages between cylinders. So that's that block. I'll take you out and I'll show you Rob's car again. Rob's car, sorry Rob, your car is being a pain again. This time obviously fixed all of the exhaust blow and then come to try and map it, gets to 5,500 RPM and just shuts down. And I'm going to show you that now. Let's do it. Whilst I was here, I thought let's show Shaheen's engine. So this has come back from machine shop. It is bored, it is homed, it is surfaced, it is masked up, and it is painted in etch primer, ready for its top coat of 2K. And then once it's 2K'd, I can clean it all again, put the core plugs in it, and that'll be that engine ready to assemble. We've got 1, 2, 3, 4, 5, 6, 7, 8 2Js built at the moment, so we're doing good. All from like 900 horsepower to like 1600, so woo, done. Let's go have a look at some manifolds. Tacking up, baby, tacking up all of these, ready to be cleaned and then welded. These are our billet collectors, billet mergers, and my little jig, and I can mount everything all up and then make all the pipes, tack them all up, scotch them all up, clean, acetone, purge, back purge, weld onto the manifold, purge, make sure it's all clean, and that'll be another GT manifold, Rohit's manifold that is. Behind me, the CNC, although it's been mint for like 6 months, 7 months, bloody spindle had an issue, so maintenance on the CNC machine. As you can see, it is in pieces, spindle's out of it, all the control circuitry's open, and I am waiting for a new spindle to arrive because it's broken. So I've made loads and loads and loads of parts. So actually some of the parts are up here. These are all my blocks and all parts that I'm making. Oil return lines and oil return lines for the turbo, and oil return for the blocks as well. So yeah, plenty busy and keeping up with everything. So everyone's working hard, making sure we try and get the cars out, and yeah, that's pretty much about it. So here we are with Rob's car, and the whole front of the engine is stripped down. Anyway, it looks beautiful, everything about this engine. So let's talk about why it's stripped down, because the distributor doesn't work on NATs very well. Unfortunately, that is just how it is. With the new ECUs, they're a lot more sensitive, refresh rates a lot faster, so with distributor they just get confused. Also, which really doesn't help, is the wiring. Although the wiring here has been done well, it's been soldered and heat shrinked, and new plug and pins and stuff. As soon as you add, another connection, and then look, we've got our shield comes down to here. That's our shielded earth here, and it doesn't continue to follow the rest of this loom with the shield and shield all of these wires from high frequency EMF or EMI from the alternator and the coils. It could be causing an issue with the trigger signal. So, and it's done this at both ends as well, the upper end as well. So, yeah, it doesn't really work very well, the distributors. Sometimes they do, sometimes they're okay, but other times they're not. So what we're going to do is going to put a proper crank sensor trigger wheel on it at the bottom. So it's got a star there, it's got a GT oil pump, so we can use a normal GTE crank sensor with that, and then we're doing the pickup for the cam sensor with a magnetic pickup and a magnet in the back of the pulleys. But I dialed all of this engine in with all the degree wheel and all the cam pulleys and everything all set up, and I've got to redo it all again. So yeah, take the cam covers off again, and then I will have to get the degree wheel on the front, all the pointer, DTI gauge, plug out, rocker covers off, DTI gauge on number 1 inlet and exhaust, and then redial it all in. But that's what you got to do to make the engines perform. That's what you got to do. So that's my fun. Anyway, thank you for watching, thank you for keeping up with the channel, and peace out.